Hey guys, what's up? So today we're going to be looking at comparing, right? Comparing the three measures of central tendency. Cool. So the first one we're going to look at is the mean. Remember the three measures of central tendency that we use is the mean, the mode, and the median, right? The mean, the median, and the mode. And we're going to look at the advantages of the mean. The first advantage says it's the most commonly used measure out of the three. So out of the median, the median and the mode. Let me just write them over here. Uh, the most commonly used measure is the mean. Okay, it's true. Everybody always wants to know the average. Let's say you do, well, when I did GSAT, we did what, five subjects: math, English, science, social studies, and communication task. And everybody would ask you, what was your average, right? So that's pretty much the one people love to use the most. Or people might say, what's the average height of a basketball player? And that's probably like 6'5", you know what I mean? 6'5". Or they might say, what's the average height of a midfielder? And it's probably about 5'9". Midfielders in football are actually really short. So it really depends. But people usually ask for the average first, which is the mean, right? And it can be easily calculated. That's so true. All you have to do is add all the numbers and divide it by the number of numbers. All the information in this should be set. All the informations in this set of data is used in its calculation, and that's true. It can interface with further statistical calculations, which is true. You can use the average to show with other calculations why the average is important in relation to whatever normal distribution or whatever the case may be. And the disadvantages is that it can be greatly affected by a single value extremely low or high. And that's very true. Let me use an example for that. Let's say you have numbers. You have 10, 11, you have 12, and then all of a sudden you have 1000. That's just gonna totally change the mean. Like totally. Let's say you just had these three numbers first, and another person comes here with 1000. That's gonna totally drastically change the mean. Because before it was, if you add 10, 11, and 12, you should get, uh, hmm, you should get 33. And if you divide 33 by 3, you should get 11, right? Now, if you add 1000, it's gonna jump from 11 to like 500 plus. You're not, well, not 500. It should jump to like around 250, actually. It should jump to around 250, which is a huge jump from 11 to 250. So I'm just trying to show you guys that it's true. It can be greatly affected by one single value. Um, it can sometimes give so we're finished with one, and it can sometimes give an impossible value when the data is discrete, especially when the expected value is a whole number, right? And the next one says it cannot be obtained graphically. And it's true, you have to find the average. It's kind of difficult to just look on a graph and say, okay, that's the mean. You have to find the average of every exact number. And this is very true as well for the mean, because it says it sometimes can give an impossible value when the data is discrete. That's true. Suppose the data is not really handling numbers. The data might be handling different things like names or just different types of information. Then you wouldn't necessarily, for example, let's say you want to know who, like you're doing an average, or you're doing an assessment of who is the most attentive in class. You can't really do an average of a person, right? Um, so there are times when it can really give an impossible value when the data is discrete. And right, so this is actually, we can see the clear advantages and disadvantages of the mean. And we're gonna move on to the mode now, guys. We're gonna move on to the median actually to see what the advantages and disadvantages are there. All right, guys. So now we're looking at the median and we're looking at the advantages and disadvantages. And the first one is it's very simple to understand, and that's just so true. It's just a middle number. So if you have 1, 2, and 3, you know the median is the middle one. So easy to understand. It's a breeze. The second one says it is not affected by extremely high or low values, and that's really true too. So let me give you an example of that. Let's say you have 1, 2, 50, 100, and 1000, or 10,000. Yeah, let's use 10,000. It doesn't really matter that these values are so big because this is the middle value, so that's the median. Q2, right? That's the median. So Q2 is actually easily understood to find the median. The median is always represented by Q2, and yeah, it's not affected easily by high or low values, and it can be characteristic to the set of data and sometimes represents an actual number. So right, that it really is. It is characteristic to the set of data because it's always in the middle based on the situation. So once you can see the middle, you have an idea of the whole set of data just from one actual number, right? Just from that representation of the middle, you can get an idea of what the graph may be like or what the set of data will be like, right? So disadvantages, it cannot interface with further statistical information, and that's true. Once you find the middle point, that's about it. You don't really use it in any other calculations. Um, in a limited set of data, it may not be characteristic of the group, and that's really true. It depends on the type of data you have. It may not give you a proper representation of the group. And the last one says in a group frequency distribution, it is mostly estimated from a cumulative frequency curve. And that's true. When you find the n plus 1th, half of the n plus 1th rank, most of the time we actually end up getting something like 50.5, and then we have to use the 50th and 51st amount. So we basically estimate it. When we use that cumulative frequency curve, and we draw the ogive, which you guys are gonna do soon. I'm gonna use that as the last video because this usually comes on the exam. It's usually an estimate. It's mostly estimated because it's not like an exact value. So those are the disadvantages of the median, guys, and I think it's fairly common sense advantages and disadvantages. And we're gonna move on to the mode now. Okay. All right, guys, great. So we're gonna be looking at the advantages and disadvantages of the mode. And the first one says it is very simple to understand, and that's really true. Let me give you an example. If you have 1, 2, 2, and 3, then clearly 2 is the mode because it occurs the most, and that's really simple to understand. Also, it is not affected by extremely high or low values, and this is really true. So for example, let's say that we add a value to this ascending order set, and this is 10,000, then the mode would still be 2. It doesn't matter that this 10,000 value was added to these numbers. So it's not affected by extremely high or low values, and it is easily obtained from a histogram, and that's really true. Usually when you have a histogram, you have the bars of how high everything is, so all you have to do is just choose the highest one with the highest frequency, and you'll find it easily. And it is user friendly, and that's very true. Uh, you can use it for many different things in order to find whatever you may need to find. Now, the last one says the disadvantages here. So we're going to look at the disadvantages. It cannot interface with further statistical calculations, and that's true. We mostly use the mean. We mostly use the mean for that instead of the mode. So we don't really use the mode for any statistical calculations, and that's true. It cannot be determined exactly from a group frequency distribution. And that's true. You basically estimate it if you can, but you cannot determine it exactly. And it says a set of data may have more than one mode, and that's so true. And that's kind of really annoying in my opinion, because sometimes you're looking through and you're saying, wow, two could be the mode, and then you realize that if you have one here, then this is also the mode, which is rather annoying. For example, if we put another 10,000 here, then this is also the mode again, so we'd have a trimodal mode, and that's really annoying, knowing that the values of the mode could be far apart, you know. All right, so I think we compared all the measures of central tendency now. We compared the mean to the median, and to the mode. All right, and we should be totally fine going forward. All right, guys, and I'll see you guys in the next section. What we're going to do is actually we're going to see when we should choose which measure of central tendency we should choose based on the situation. Okay, that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.